Number 15. Talking about the Daytona 500. The winner leaves the racetrack and goes towards the winner's circle at a speed of 120 miles an hour. Okay, and so it says, according to the formula S equals the square root of 21D, the distance required for a car to come to a complete stop once the brakes are applied, or what's the distance when the brakes are applied. Okay, and I think elsewhere it said that the speed is in miles per hour and the distance is in feet. So we don't have to do any fancy conversion here. We just plug in the numbers. So the speed is 120. It's equal to the square root of 21 times the distance required to stop. So the first thing we're going to have to do is square both sides. The square and the square root cancel each other out. We're just left with 21D over there. And then 120 squared is 144 with 2 extra zeros. Now, I think you know what to do from here. Let's divide by 21 on both sides. And we get that the distance required to stop is 685.7 feet. Easy enough. You just got to know where to put the numbers. Number 16, we're using the same formula to express the length of a skid mark, D as a function of speed. Okay, so what this is asking us to do is just switch what is on this side of the equal sign. So this shows the speed as a function of the length of a skid mark. We want to know if we know the speed, how long would the skid mark be? So we're just basically doing the inverse of this function. Okay, so we want to get D by itself. We got to square both sides. S squared is equal to 21 times D, and we divide by 21. So this is the same exact process that we did in number 15, but what we come out with is not a specific distance. What we come out with is a formula, just like the original formula, that we could use to find the distance for any speed. Okay, so distance of a skid mark is equal to the speed squared divided by 21. Okay. All right, let's move on to number 17. Number 17, we have some accident investigators who are using that same formula we just talked about, because they want to know the speed of a car because they have the length of a skid mark. Okay, so they come up to a crime scene or where a car has had an accident, and they want to know, was this person driving safely? Were they driving too quickly? What happened? And they observe a skid mark that is 120 feet long. Approximately how fast was the car going if the skid mark was 120 feet long? Well, we know that speed is equal to the square root of 21D, and we know that D is 120. 21 times 120, we take the square root of that, and we get that S is equal to 50.2, not feet, 50.2 miles per hour. So depending on what the speed limit was here, it looks like they were going at least kind of a reasonable speed. Okay, so we got 50.2 miles per hour. And the units are important. If you put 50.2, 50.2 what? You know, because then, you know, maybe I have to assume that you think it's feet. Or if you put that D is equal to 685 miles per hour, it doesn't make any sense. That's ridiculously fast. So be careful with your units. Make sure that you have the right unit. Number 18, just two more left. Zoom in a little bit. So number 18 is talking about the flight of a rocket, and it can be modeled with this equation. The height of the model rocket is equal to negative 16 times t minus 1 squared plus 16. where h is the height of the rocket in feet, at a time t seconds, which equation represents the function as, represent time as a function of height. So what we need to do again is we need to move everything from this side of the equation that isn't t to the other side so that we can get t by itself. Okay? And if we're doing inverse operations, so we're subtracting since we were adding here, then we have to go in reverse order of operations. So instead of doing addition and subtraction last, we're going to do it first. H minus 16 is equal to negative 16 times t minus 1 squared. Oh, I get it, model rocket, t minus 1. Okay. Sorry, that's over. Now we divide by negative 16. Negative 16s divide out. Let's go back over to this side up here. We get that h minus 16 over negative 16 is equal to t minus 1 squared. So now we're going to have to take the square root of both sides to get rid of that. Now that's under a square root. And then the only thing we have left to do, sorry, video people, is to add 1 to both sides. So what we come out with is that t is equal to the square root of h minus 16 over negative 16 plus 1. So which one of these is that answer? We've got some plus or minus square roots of h minus 16 over negative 16 plus 1. So it looks like A is the answer. Let's look through the other ones. This one doesn't have the negative sign. This one has the negative 16 out here. This one has a minus 1 at the end, which is why it's wrong. And then they all have this h is greater than 0, less than or equal to 16. And so why would that be important, I guess, is what we need to think about here. Let's look at our, because that's what number 19 asked us about. One or two sentences explain why the height of the model rocket must be between 0 and 16 feet. Reference your equation from number 18 as part of your explanation. Okay, so for starters, let's talk about why h would need to be greater than 0. I'm not going to write in these complete sentences, but you are. H greater than 0, greater than or equal to 0, because height only makes sense if it's positive. Right? You don't launch a model rocket and then it goes into the earth, has a negative height. You launch and it goes up. Even if it only goes up a couple millimeters or something, it's still going to go up. So the height needs to be positive, but why does it have to be less than or equal to 16? So that's where we're going to reference this equation over here. So what would happen if our height was greater than 16? Okay, so let's say our height was 17. You plug that in. You get t equals the square root of 1 over negative 16 plus 1. You starting to see the problem yet? T is equal to the square root of negative 1 over 16 plus 1. Okay. For the folks at home, what is the square root of negative 1 divided by 16? It's a non-real answer. So the reason we have to restrict the domain to h is less than or equal to 16 is because if we allow the part underneath the radical to become negative, we start to deal with non-real answers. So h needs to be less than or equal to 16, or else the part under the radical will become negative. So that's your answer for number 19. Use your own words. Okay. There's a review. The first part of the review, other video for the problems on the last page.